Hi everyone, I'm Christina and welcome to video 12 of our A-level mathematics calculus series. In this video, we're finishing off differentiating expressions with powers of x, and our objectives are to go through further worked examples. So continuing on from the last video, this is example 3, and we want to differentiate the function f of x equal to 2x to the power of a third plus 3x to the power of 2 over 3 all over x. So the first step we're going to take is to try and rewrite this function a little bit. So we want to differentiate each term, which is a power of x. So what is easiest to do is divide each of these terms by x. So we get rid of our fraction. So 2x to the power of a third over x plus 3x to the power of 2/3 over x. So we get two terms that we can then differentiate. So remember our laws of indices here. So 2x to the power of a third over x is 2x power of a third minus 1 plus 3x to the 2/3 minus 1. So we'll go over the index laws in another video, but we're using them here to combine our x's. So we can write that as 2x to the minus 2/3, since we're doing a third minus 1. And then we can do the same thing for the second term. We're doing 2/3 minus 1, that's minus a third there. So now we want our derivative f dash of x. So let's have a look at the form that this is in. So this is in the form of ax to the n, and we can call it a1 n1 plus a2x n2, since we have two separate terms that we want to find the derivative of. So to find f dash of x, we know, well, f dash of x for f of x in this form is going to be a1 remains. We bring down our n1 from here, and then we write x to the power of n1 minus 1. And then we do the same thing for the second term here. So that's going to be plus a2 remains. We bring down n2, and then we have x to the power of n2 minus 1. So then if we actually stick in some values that we have from our function here, well, we can see that a1 is going to be 2. So a1 is 2 here. Our n1 is our actual value in the index here, which is minus 2/3. And then n1 minus 1 is minus 2/3 minus 1. And so what's that going to be? That's minus 5 over 3. So we're just taking away minus 2/3 minus 1 over 1. You can make the denominators the same, and then minus the fraction. And then we do the same thing for the second term. So a2 is 3. And then n2 is our index value here that we bring down. So that's minus a third. So n2 is minus a third. And then n2 minus 1, that's minus a third minus 1. That's equal to minus 4 over 3. Okay, so now let's actually put those values in to get our derivative. Let's put the derivative down here. So what is f dash of x? What's 2 times minus 2/3, x to the power of minus 5 over 3, plus 3 times minus 1/3 times x to the power of minus 4 over 3. So let's clean that up. So we get minus 4/3 x to the power of minus 5 over 3 minus 3 times minus 1/3, that's minus 1. So then we can just write x to the minus 4 over 3. And then we have the derivative of our function f of x here. Okay, so example 4, we want to differentiate the expression y equals 7x plus root of x. So y is our f of x here. And we want to find f dash of x, which is our dy over dx. And that's the notation we can give our final answer in, since the expression is in terms of y. So first, let's have a look at how this is written. Y equals 7x plus root x. It might be easier just to rewrite this as 7x plus x to the power of a half. And now, again, we can just compare it to a general form of our function that we can differentiate. So that's a to the x this time. So remember that one, when we differentiate a times x, we just get a plus, if we have x to the half, well, this is just in the form of x to the n, where technically a would be 1 here. So now if we want to differentiate this, we can see here that a is 7, and then our n in our second term is just a half. So our dy over dx is equal to a for that first term. When we differentiate a times x, we get a, and our second term is going to be n times x to the n minus 1. So we brought down the n, and then we minus 1 from the power. And if we have a look here, our a is 7, our n is a half, our n minus 1 is a half minus 1, which is minus a half. And so if we plug those numbers in, dy over dx equals 7 plus a half x to the minus a half. And so for our expression y equals 7x plus root x, we can just say dy over dx equals 7 plus x to the minus a half over